Okay. Does this... Is this on?
Yes.
Yay. Excellent. Hello. Welcome to the second talk in a row. And I've got another one this afternoon, and I'm doing a pub quiz this evening. And I'm doing PubConf on Friday. If you're not who's going to PubConf? You've got to go to PubConf. It's fantastic. Watch all the proper speakers make complete idiots of themselves. Yes, come, drink. Mainly drink, actually. It's funnier if you drink. So, yes, brave new .NET. You may just have seen my other talk about why I'm not leaving .NET, and this is where I'm going to dig in more into new .NET and .NET Core and ASP.NET Core and what's good about it and the new stuff that you need to learn. Because .NET is now a proper cross-platform, standalone, modern, open source programming language, environment, framework, platform thing. And that means that there's a whole bunch of new stuff that you need to learn. The good thing is that you can forget all the IIS stuff and all that XML web.config stuff and all those PowerShell commands. You can just forget all of that and learn nice, easy bash commands and JSON configuration and maybe some YAML or some ini files and environment variables and that sort of thing, because we have new .NET. We don't have old .NET anymore. Old .NET was big and slow and it only ran on Windows, and if you look on the Tech Empower benchmarks with old .NET, it was doing somewhere around 23,000 requests per second for the plain text benchmark. It was not quick. It was easy. It was very easy to build applications with old .NET, but they were big and slow, and they were quite expensive to run because you had to have Windows servers and SQL boxes and all this sort of stuff. And now we have .NET Core, which is light and fast and agile, and this is a Thompson's Gazelle, which is in the top 10 fastest animals on Earth, because I didn't want to do the cheetah because it seemed too obvious. But yes. And .NET Core cross-platform runs on Linux, and so now we can spin up Linux boxes and using Terraform or Vagrant or whatever, and we can deploy our .NET Core code, and we can just pick up the entire thing, the CLR and the runtime and the SDK, and we can just bundle it all up into a zip file or a tar file and then dump it on a Linux box, and it'll just run. And pretty soon, I don't know if it's in this year or maybe early next year, but you'll be able to do native compilation. You'll be able to use core RT and do that /t:/link native thing and just create a single native executable file that is your entire web application, and just pick it up and put it on a machine and go run that, and my web application is running. And so there's all this new stuff and all these new things that we need to learn. And of course, we're developers. And if there's one thing that you can say about developers, it is this: we fear change. We're not good with it. We don't like it when you move our cheese. And so I just want to kind of go over some of this stuff and show you some of the really cool things that you can do with new .NET that people who've been doing things like Node and Ruby and Python have maybe been taking for granted for all this time. This so we'll kind of cover the basics, and then I'm going to talk a bit about Docker, and then I'm going to talk a bit about microservices, because .NET Core and ASP.NET Core are great for building microservice architectures, much better than traditional .NET. When I was still doing traditional .NET and ASP.NET MVC and Web API 5 point whatever the hell it's on, and having to deploy into IIS, app pools and so forth, and people started talking about microservices, and I was kind of like, that sounds just really complicated, and why would I want to do that? Once you get into lightweight, standalone executables that you can just deploy and put in Docker containers, and you get a proper nice DevOps, continuous integration, continuous deployment pipeline, this stuff starts to make a lot more sense. But then once you start creating microservices, you go, hang on, there's a whole bunch of other stuff that I need to start worrying about now, because I've got this one running over here and this one running over there, and I need to worry about partitions and performance and all sorts of other stuff. So I'm going to talk a bit about that kind of thing. So to start off with, new things that are mainly different. So the big difference for an ASP.NET Core application is that it runs on Kestrel. And Kestrel is Microsoft's new .NET-based web server. It's a console application. So when you create an ASP.NET Core application, you go .NET, new, MVC, it creates a console application. And it's got a program.cs file, and the program.cs file creates a web host and then runs it. And then that carries on running until you press Control-C or kill the process. And so this introduces, there's no IIS. You can put it behind IIS. If you run it on Windows and you install the IIS module, IIS is actually just acting as a reverse proxy to the Kestrel web server. So there's none of that integrated pipeline that you got in ASP.NET 4.5 or 4.6. So this is just a console application, so the configuration story has changed. And one of the things that you start using a lot more with ASP.NET Core is environment variables and alternative configuration sources. So we're going to look at some of those. And so I've created an application. This is an application that I use when I do my workshops. And we build this up over a couple of days. And it's incredibly silly, but it's just very useful for sorting out the stuff that we need to demonstrate. Excuse me, I've got a frog in my throat. Is that an expression in Norway? I'm guessing probably not. So, this is my application. Rocket stop. I'm getting ahead of the curve here. I figure that when Elon Musk starts sending regular transports to Mars, that's like a 6-month journey, even when Mars is at its closest point. So I'm going to hook some asteroids and put them like every month along the route to Mars, and then the rockets will be able to stop and people will be able to get out and use the toilet and that sort of thing. So I'm getting ahead. I haven't worked out the asteroid bit yet, but I figured I'd start writing the software to manage these rocket stops along the way. Okay, so I've got my rocket stop application, which I need to exit PowerPoint and then do the Alt-Tab thing. So here is rocket stop. This is running in Visual Studio Code, and I've got my rocket stop web application here with my docking controller and my home controller. And that's my sort of MVC application. And then I've got an API application here, which is a microservice, and this is handling the docking data. Okay? Now, running these things as microservice. So if you do this in traditional .NET, you end up with 2 web applications, and in the kind of properties page, they'll each have a different port, and you run it on localhost something and localhost something else. When I'm working with a .NET Core application, an ASP.NET Core application, I have to run them both from the command line, and they will default to running, Kestrel defaults to running on localhost 5000 if you don't tell it differently. So, and this is ASP.NET Core 2 as well. Where's my CS proj file? So yes, there we go. So you see I'm targeting NetCore app 2.0 here. And the really nice thing, I don't know if you've seen this yet. If you went to any of Damien or David's talks, you might have seen this. But now there is a single meta package that you have to reference called microsoft.aspnetcore.all, and that just pulls in the entire set of ASP.NET Core. So it's logging, configuration, dependency injection, MVC, Razor, the whole lot. The nice thing is that now when you publish your application, even if you publish it in standalone, it runs an analysis over it and works out which DLLs you actually need and only bundles those in. So if you don't use Razor, it won't pull in Razor and that sort of thing. So talk a bit more about that later. Ignore the other things that are there at the moment. But I've got, so I've got my NetCore application there. So if I want to run that, I need to be able to tell it that I'm running in development mode, because I've got some code in my program CS here. So this has got a lot shorter as well. This is now just create default builder on web host. So all those things that in ASP.NET Core 1.0 and 1.1, you had to create your configuration and hook these things up. This create default builder just does that for you now. and so it looks for a file called appsettings.json, and then if you set the environment that you're running in, it'll look for a file called that appsettings.whatever.json. So you have the concept of a development environment, a staging environment, and a production environment. Okay, so to tell it it's running in development, I set an environment variable. So I'm going to say, this is Windows command line here, so I'm going to say set ASP.NET Core _ environment equals development. Okay, and then I can start this application up by doing .NET. Now, I can do .NET run, and that will just launch it, and then if I change something, I just go back in and I kill it, and then start it running again. But there's something called .NET Watch that you can get, which is very useful. You say .NET Watch run, and it keeps an eye on all your C# files and all your JSON files and any other files that affect the build of the application. And if any of them change, it kills the process and rebuilds it and starts it running again. So it's very useful to include that in your code. All you have to do is pull in this line here. So it's not a package reference, it's a .NET CLI tool reference, and it's Microsoft.NET Watcher Tools, and the version is 2.0.0-preview1-final, because .Microsoft version numbers, which I will be explaining at PubConf. It's numerology. So yes, the one above I'll talk about a little while later on. That's just there by default. So that means that I can say .NET Watch run, and that will build my application and start it eventually. Come on. This is a state-of-the-art quad-core 16 gigabytes of RAM laptop. Okay, I do. I need to get. There is no such thing as a faster one than this laptop, unless I get one of those massive Acer Predators. Right. So but I've got my microservice, and I need my microservice running at the same time, so that my main web application can talk to my microservice. And so here, I'm going to set ASP.NET Core _ environment equals development, and I'm also going to set ASP.NET Core _ URLs equals http://localhost:5001. Okay. That's fine. It should still be working. That's just something that's not there yet that I'm going to put in later on. Okay. And so then I'm going to say .NET Watch run here as well. So this is going to run on port 5001. And this is starting up, and so this is using Entity Framework Core, again Entity Framework Core 2.0, to talk to a SQL Server database, which is where it's actually keeping track of which spaceships are docked in which bays. So there we go, connecting to SQL, connected, running the migration. Come on, come on, come on, come on, come on. So let's and find a. So I go to localhost 5000. Find out whether that's. So there you go. There's the web application running. Welcome to Moon. This is the rocket stop on the Moon. Obviously, that's the easiest place to build the first one. And then if I go to /docking, that should have. So yes, there you go. My migration ran, my initial seed data was created, and I've got my web application on port 5000 talking to my microservice on port 5001. Okay. Now, when you build a microservice architecture, the whole point is that, you know, if I had a list of bays coming from somewhere, that would be another microservice. If I had my catering, that would probably be half a dozen microservices. If I had stock control, that would be like 12 more microservices. So you end up with a lot of microservices, and it's quite difficult to keep track of all the numbers. And every time you want to bring up a complete set of microservices for testing or working with, you've got to go and have that many console windows open and just run this and run this and run this and run this. So that gets quite annoying quite quickly. So, this is sort of how you do this from the command line. You set your ASP.NET Core URLs, and then you've got to try and keep track of what's running where and everything else, which is quite annoying. And that is why we use Docker. So is anyone using Docker already for their deployments and everything else? So Docker is one of those things where people go, oh, Docker's great, you've got to use Docker. And you just go, why? I don't understand the point of Docker. And then you use Docker for, how many times can I say Docker without officially coming to a paragraph in my speech? You use Docker for a couple of weeks, and then you just go, everything must run in Docker. How did I ever live without Docker? So what Docker is just very, very small virtual machines, okay? It's actually not virtual machines, it's processes running with their own pretend file system that they carry around with them, so they have their dependencies bundled along with them, and they're run in their own kind of isolated process space. So a thing running in a Docker container can't see the other things running in other Docker containers, and it can't see anything on the host machine unless you accidentally tell it can, or on purpose tell it can sometimes, but usually accidentally. But they all share the same process space, they're all running on the same kernel, so you can run dozens of them all on the same machine. I've had like 20-something Docker containers all running on this machine at the same time, because they are just processes. They're just processes that can't see each other and can't see the actual disk. For example, the SQL Server that my application just attached to is not running SQL Server on my Windows laptop, because I like using my Windows laptop for playing Forza Horizon 3 in my hotel room. I carry an Xbox controller around just for that purpose. And every time I want to play Forza Horizon 3, I really don't want to have to bring up the services window and shut down SQL Server to stop it using 8 gigabytes of my memory. So, SQL Server now runs on Linux, and Microsoft maintain a Docker container with the current Edge version of SQL Server 2017 for Linux. And I can run that just using this, this little script here. It's Docker run in detached mode. The -D says run in detached mode, so just start in the background and keep going until I kill you. -E accept EULA equals Y, which says I accept the end user license agreement. Set the system administrator password to secret squirrel with numbers. I use that password for all my social media accounts. Please feel free to hack me and post nice things about Go. The -P 1433 says link that port, that network port on the Docker container to that network port on my machine. So it now looks as though I have a SQL Server running and listening on port 1433. And then that last bit there should say Microsoft/MS SQL Server dash Linux. I forgot to put the Microsoft / on there at the start. Okay. So yes, and I can prove that that's running in there by doing docker ps, and you can see there that I've got Microsoft/MS SQL Server Linux, and it's been up for 22 minutes because I started it just before this talk. So that was completely fresh pull, and then my migration ran, and that started up. Okay, so. And I can pull in, I've got Postgres, I've got Elasticsearch stacks and ELK stacks. Pretty much anything you could possibly want to run these days, you can get in a Docker container. So of course, you want to take your code and put that in a Docker container so you can get all that goodness as well. And so we have ASP.NET Core. So Microsoft maintain what are called base images. When you create a Docker image, you base it on an existing image. And so there's a Node base image and a Python base image, and there are .NET base images. And there's a .NET Core, there's a Microsoft/.NET base image, and a Microsoft/.NET SDK base image. And so you could download that and then shell into it and run the .NET SDK inside the Docker container without having to install .NET actually on your machine. The really nice thing these days is Microsoft have made Windows work inside Docker containers as well. And so you've got this, it's kind of complicated. So Docker generally as Linux, and it was using Linux C groups and namespaces and that sort of thing. And then Microsoft went, oh, containers, those look good, we should do something like that. And rather than doing the typical Microsoft thing and reinventing all the wheels, they worked with Docker to make Windows work in containers. And so you can get Windows Server Nano Core, and you can run .NET Core applications in that. And you can also get Windows Server Core containers, and you can run full .NET framework in that. But you still manage it with Docker. So you still say Docker pull Microsoft / Windows Server Core, and then run a load of startup things, and then you can push that, and you can run it in Hyper-V and all this sort of stuff. But everything I'm showing you today is running on Linux containers, just because it's easier for me. So there's a .NET Core and a .NET SDK, and then there's an ASP.NET Core base image and an ASP.NET Core build base image. Okay, those are two separate things. Until recently, when I was doing my talks and my demos and my workshops, we would just use the SDK image or the build image, and the Docker file for that would look something like this. So here we're saying the first line of any Docker file is from, which is saying this is the base image I want to use to build my Docker container. So we're saying from Microsoft ASP.NET Core build. Workdir is essentially, it's like CD, but Docker remembers it. So every time the container starts up, that will be the working directory. And then the copy ... says copy everything from the current host directory where I've run Docker build into the app directory as it is now on the Docker image. Then run .NET Restore, because you've got to pull down all the packages that you need to run your .NET application, your ASP.NET application. Then run .NET Build, and then set the entry point to .NET Run. And so then when the container starts up, it'll use that, and it'll just say, I'm in the app directory, I'll do .NET Run, and your application will start up. Okay? The problem is that the ASP.NET Core build image itself is enormous. It's like 2 gigabytes because it's got all the build essentials and the C++ SDK and all sorts of other stuff and the whole Microsoft build pipeline and MS build and everything else. So it's enormous. The other problem with that is that although you've built the application, so when it starts up, it is just running a pre-built application, all your source code is still in the Docker container and in the Docker image. So anybody who wants to can just pull that Docker container down, start it up, shell into it, and get all your source code out. And frankly, if I wanted to ship my source code, I'd be doing Node. I would rather build my source code and keep it all to myself. So there was a hacky kind of way around this where you would have a two-stage, what we called multi-stage Docker build, okay? So you had one Docker file that did the build, and you would either mount a volume into that Docker container, or you would access the files inside that Docker container afterwards, and you would copy the published output from the build into another Docker image, and then that would be the thing that you actually shipped, okay? But Docker, this happened. It's still like the standard way of doing it. But in the next version of Docker, which you can get if you download the Edge build from docker.com, they have actually gone, you know what, everybody's using this pattern all over the place, let's just support it out of the box. And so now we have a multi-stage build Docker file. So now we can do this. We can say from Microsoft ASP.NET Core build and give it a name. So we give that image a name in our build process. Create a new workdir, and I'm going to call this src to differentiate it. So this is where I'm putting my source code. Copy everything into it, run .NET Restore, and then run .NET Publish, and set the output to /app, which will just get created, and set the configuration to release, so we don't get a debug build out. And then in the same Docker file, I put another from. and this is coming from Microsoft/ASP.NET Core 2. Okay, so this is just the runtime. So the build image is about 2 gigabytes. Okay, it's big. That's big for a Docker file. The runtime image is about 200 megabytes, which is actually quite small. And it's going to get smaller. Once they get this working on the Alpine thing, that base image is probably going to go down to about 50 megabytes, which is tiny. And then on my second line in the second block, I'm saying copy -- from build. So go to that image you built in the first stage of this build and just copy the files out of there directly into here, and then set workdir to /app on this new image, and then do the entry point .NET and just run rocketstop.dll. Okay? So, and I'll just show you what the output from a publish looks like. So just do a .NET publish -out ././out.
You know we can't see it, right?
Nope, I do not know that. Hang on. It's all right because I'm mucking it up at the moment. Yes, it is. Right. There it is. There's the command that I got right first time while you weren't looking. Okay, so this is an MVC application. This has got CSHTML files. This has got Razor views in it, okay, which has always been fun for kind of building stuff. So if I go to my out directory here, which I've just created, you can see that what we've got a www root folder, so that was included in my publish. That's all my JavaScript files and my CSS files and everything else. We've got rocketstop.dll, which is my application, which is 24K. And we've got rocketstop.precompiledviews.dll. And that is all my CSHTML files that have been pre-compiled in advance and bundled up into a DLL. So even the source code for your Razor code isn't shipped with your application. We don't need to ship the views directory anymore, which is pretty neat. That is what this line here is doing, the Microsoft Visual Studio web code generation tools. It pre-compiles your CSHTML files into a DLL and deploys those. Okay, so that's what's being created, and then that's what we're copying onto our Docker image from in our multi-stage build. So if you want to get that, it's going to be in the next version that is officially released, but which was supposed to be in May. Still hasn't actually landed yet, unless it's landed since like 11 o'clock last night when I wrote this talk. It's not true. But yeah, if you get the Edge build of the community edition of Docker, then you'll be able to do this multi-stage build thing, and it is very cool. My favorite thing about it is that if you wanted to do a multi-stage build, you actually had to use a proper, complicated, continuous integration process like Jenkins or TeamCity or something like that, because you had these 2 Docker commands and 2 separate Docker files. Now you've got this multi-stage build within a single Docker file. You can just attach your GitHub repository to your Docker Hub repository and set the automated build process so that when you do a commit to a particular branch on your GitHub repository, the Docker Hub will do a pull and build the Docker file, and then that just becomes the new image. So that combination of GitHub and Docker Hub just becomes your entire CI process. Obviously, you still want to run some tests. Oh, yes. Okay, so now I've got my Docker file in my Rocketstop things here. So here's my Docker file for my main application, and here is my Docker file for my other application. And the only difference there is that this one's running a different DLL down at the bottom here. Okay, so I want to start these up, and what I would normally do for that is I would do src /rocketstop. So to build this manually, I would say docker build -t manual rs dot. Okay, and that'll go through, and this is running. It's running .NET Restore over the NDC shared Wi-Fi. So everybody hates me now, and it's creating this Docker container. It's done the restore. I'm slightly concerned that I've got Forza Horizon 3 running in the background somewhere. I think. And then I would start this up with Docker run. Oh, you couldn't connect to the server.
Oh, that's good.
I may possibly be about to hate my life. Okay. Let's just kill that then. Right, it doesn't matter because I've already got them built, so that's okay. Right, so then I would run that with Docker run, and if I go to Docker images, you can see that I have got an image here. Right, so this none here is the one that I've just killed, and you can see that's 2.18 gigabytes. This is one I prepared earlier, which is local/rs, which is my local copy of RocketStop, and that's 305 megabytes, which is pretty small for a Docker container. And you may be thinking, you know what, 2 gigabytes isn't that big for a Docker container, but bear in mind that one of the places you can run Docker is on Internet of Things micro devices. You can have like a Raspberry Pi Model B, and you might have a 4 gigabyte SD micro card stuffed in there. So actually 2 gigabytes is quite a lot, and there is a big difference if you're deploying to these things. And Docker are really pushing on the Internet of Things use case as a way of deploying their code. So it is worth shaving off those 1.8 gigabytes when you do your build step. Okay, so then I would say Docker run -p 8080:80 local/rs, and this will start up my my container, and so you can see that's now running, and it's listening on port 80. Okay, so the ASP.NET Core base image sets that ASP.NET Core _URLs environment variable to 80, which is obviously the port you want a web application to be listening on. It's going to run all the applications in all the Docker containers are all going to be listening on port 80, but they're listening on port 80 in the container, not on the host machine. That -p command that I passed in there, so I told that to run on 8080, didn't I? So I'm going to go to localhost 8080, and that's the code running inside the Docker container. So I've bound port 80 inside that container to port 8080 on my actual host machine. It's nice and easy. That way you can just publish all your ASP.NET Core containers. You know that they're all going to listen on port 80, and then you can just do whatever you want with that when you're binding them to your actual host machine. Okay? But now I would need to spin up the other Docker container with my rocketstop.docking service inside it, and then find a way to maybe bind that to a different port, bind it to 8081. But actually, the process running inside the Docker container can't see any of the stuff on the host machine, so I have to figure that out. So I am going to use Docker Compose, okay? So Docker Compose is yet another layer of abstraction, if you like. Docker Compose lets you say, this is what my entire cluster of microservices looks like. All the dependencies, all the databases, everything, and all my services, I'm going to spin up with a single command. And you have a Docker Compose file, which is a YAML file. See, I told you you're going to need to learn YAML. So this is Docker Compose, and you basically set up all the services that you need and all the networks that you need as well. So you create virtual networks between the different Docker containers so that they can see each other. So in this instance, I'm creating a network called RSNet, RocketStopNet, and the driver is Bridge. If I was to take this and run it in production, I would spin up a Docker swarm somewhere in a data center and use something similar to this, but I would use an overlay network which would allow all the containers on the swarm to see each other. So my Docker Compose file is down at the bottom here, and it looks like this. Can't see it because I've still, yes. Ah. Okay, got it. Right. So this is my Docker Compose file. So up at the top, I've got my SQL Server Linux. This is going to spin up a new SQL Server Linux box. And I've got a rocketstop_docking. And I've got, I'm saying this is the image. If you can find the image, just run the image. If you can't find the image, use this to build a new copy of the image. I've got the Docker plugin for Visual Studio Code, which is why I'm getting these nice pop-ups telling me what the hell I'm doing, which is very handy because I don't know. I'm going to set an environment variable. So ASP.NET Core's configuration builds up in layers. So you've got your app settings.json, then app settings.development.json, and then environment variables, and then command line. So I can override what's in connection strings docking DB by setting this environment variable. That's a double underscore as the separator on those. So that will tell the docking service to use MS SQL as its data source. Okay. And you can see we've got the password secret squirrel there. That data source name is the name of this service here. Okay, so that's going to get hooked together. The DNS server that's provided by Docker on the bridge network, when you look for MS SQL, will return the IP address of that MS SQL Docker container. Then rocketstop, I'm going to set its services docking to point to http:/rocketstop docking. So that'll be able to see this container once I bring that up. And then down at the bottom here, I've got a whole load of other stuff as well for Influx and Grafana, which we're going to be looking at in a moment. Okay, so let's stop that. And we'll do docker-compose rm just to clean up any containers I may have had already. And then I'm just going to say docker-compose up. Okay, so that's spinning up all these different Docker containers. This is creating me an entire microservice cluster on my development machine. Okay, and everything's running here. And I've got a thing saying login failed for user SA and failed to explain there. But then, yes. So you get into this interesting thing. I'm going to show you some of the code that does this in a moment. When you're bringing up this microservice cluster, you might have your application starts and tries to run the migrations before the MS SQL container has actually spun up and started accepting incoming requests. So you end up writing an awful lot of code like this. Where's my data docking context init? So because I'm spinning up a brand new SQL Server instance, every time I run this, I'm spinning up a brand new SQL Server instance. So my database doesn't exist. It's not like when you've got MS SQL, whatever the application, I can't even remember what the application's called. Studio, Management Studio. You can't do that and create the database and then run the migrations and everything. You're having to run the migrations as part of the startup. So I've got this thing that retries for a minute, waiting for the database to start up. And I have to pull in the connection string and then change the database to master, because obviously docking DB doesn't exist yet. So yes, there's lots of fun going on in there. So we retry 6 times and wait 10 seconds between each one. But now I've got that up and running. And if I go back to my Docker file, we can see that I told it to bind rocketstop to port 8081. So that should now be showing on there. Okay. Yes, it is. And if I go to /docking, and I can docker ship and put it in base C, and we'll call it Vogon constructor, and dock that one. And so that's going in there as well. Okay, so that's everything is all just brought up and running, and I can check this code into GitHub, and somebody else, as long as they've got Docker installed on their machine and running, can do a git clone, Docker compose up, and get an entire microservice architecture with all the dependencies up and running. If Docker can't find the image that's in the Docker compose file, it will try and pull it from the repository. If it's not on the repository and you've got a build thing, it will build it for you. Okay? So this makes microservices really, really, really easy to work with. except you've still got a whole bunch of other stuff that you have to worry about when you're building this sort of thing. So I took a look, once I'd started getting into this whole kind of ThoughtWorks, Martin Fowler buzzwords thing, I thought I'd go and look at what's happening in other ecosystems that have been doing this architecture for a bit longer. And I found Java has a couple of framework kit things called Spring Boot and Drop Wizard, which have got a whole bunch of bits and pieces that are very useful for doing microservices. Go, if you like that sort of thing. My microphone feels like it's falling apart. Go has something called Go Kit. And so I was looking into what these things have in them. And the big thing that becomes important with microservices, if you've got one application and everything's included in that one monolithic application, it's very easy to know if everything's okay. You hit the application and it's either there or it's not. Once you've decomposed that into 100 microservices, you've got 100 things to keep an eye on, and so you need some sort of monitoring in there. And there are various aspects to monitoring. You've got to make sure that all these services are healthy, that they're all running right, that they're all working at the right time. Seriously, this is falling off. Okay, so you need something for logging, and actually for ASP.NET Core, for logging, we've got logging. There's iLogger Factory, and you can attach things to it, and you can attach Serilog and Log4Net to it, and then pipe the content onto Azure Table Storage or a SQL database or Elasticsearch or Splunk or wherever you want it to go. Okay, so logging is taken care of. But you also need metrics, and metrics is not the same as logging. Logging is information about stuff that has happened. Okay, metrics is statistical information about how long it took, how often it's happening. It's that metrics are the sort of things that you can do lovely, pretty dashboards from. Logs are the things that you go and search in when something's gone wrong to figure out what it was. Okay, so you've got metrics, and then you've also got health checks. So you need to be able to go to a service and say, are you healthy? And that doesn't just mean, are you running, can I ping you? It means, if I ask you to do something to the database, are you going to be able to do it? So the health check endpoint has to say, right, I've got I know this is my database connection string. When you hit the health check endpoint, I'm going to open that connection and return OK as long as the connection opened OK. If the connection doesn't open, I'm going to return an error code, and you will know not to direct any more requests to me. Okay? Insanely complicated, it turns out, these microservices. And then you've got circuit breakers, and circuit breakers are wrappers around the API boundaries between the different services, and the circuit breaker pattern says you might sort of in background just ping a health check on one of your dependent services and say, are you there, are you there? Or you might have a circuit breaker that you wrap around an actual operation, and you say, if that operation fails twice, stop trying it for 5 minutes. And then pick up trying it again, so you don't end up spamming all your other services with potential denial of service attacks. Okay, so these are all the different aspects of monitoring. Logging, like I say, we've got covered with Microsoft.extension.logging. I went looking for the metric side of things, and there were a few ports of the Drop Wizard metrics library, the direct ports of the Java library, and they're all at various stages of abandonment and so forth. And then I found AppMetrics, and the website for that is appmetrics.io. And AppMetrics, a guy called Alan Hardy does this. It's bonkers. It's one of the best bits of .NET open source I have ever seen in my entire life. Okay, so remember that address. I'm going to demo the stuff that's in there now. So we've got, these are your metric types. These are the types of data that you're going to pull out. And the first one is called AppDex, and this is Application Performance Index. This is an industry standard, and it says, is this service performing within expectations? You can set what those expectations are, but it's like a user satisfaction index. If you put this on your website, it will say everything's okay if you're serving your kind of main web page out in under 100 milliseconds. If it's taking over half a second, it'll say, no, that's useless if it's gone down. So AppDex is the dashboards that you use understand AppDex, and you can create dashboards based on it. Then you've got counters, which is just how often has this thing happened, or how how many times has this thing happened. You've got gauges, which is just a single number that changes over time. So you might say how many users are currently active on the system would be a gauge. So I've got, every time someone logs in, you add 1 to this number, and every time someone logs out, you take 1 away. And so you can map that over time as well. You've got histograms, which is when you say, so there's less than 100 milliseconds, less than half a second, less than a second, more than a second, and get a distribution of values over there. You've got a meter, which is how frequently something is happening, so how many times per minute, and how many times has it happened in total. And then you've got a timer, which is like a meter and how long it took at the same time. So you can see this is happening this often. On average, it takes this amount of time. You can link that up with a histogram. It's all incredibly complicated. Okay. AppMetrics adds endpoints to your application so that you can pull this data out. And the 3 simplest ones are /metrics, /health, and /ping. /ping just returns pong, and it just goes, yes, this process is running. We're going to take a look at metrics and health, but before we do that, I'm just going to show you how easy it is to include this in your project and why I am so impressed with it. So we have 4 references that I've added to my application. The AppMetrics core. This, it doesn't specifically say it'll work with a NetCore app too, but it will. It's not touching any of the internal stuff, or none of the stuff that it's touching internally appears to have changed in a way that stops it from working. Then we've got the MVC extension, which means it knows about the ASP.NET Core MVC framework and can hook into various things in that. We've got an InfluxDB reporter, which we'll look at shortly, and we've got the JSON formatter, which is the thing that's going to hit these endpoints. Okay, and then to hook this up, it's a big chunk of code to hook the middleware up to do this. Okay, it's not that. It's this. Okay. So, we've got our configure metrics function here, but the thing is, this will be essentially the same for pretty much every application you create. So I'm tempted to kind of create a NuGet package of my own that just has my standard setup for this, has all the dependencies for those 4 things so that I can just install my NuGet package and just have this configure metrics. The only thing that's really going to change from use to use is where my InfluxDB is, that I'm going to be reporting stuff to, and my default context label, which is essentially what I'm going to mark all my metrics with. So I got this. I've got my service collection here, which is where I'm registering my dependencies, and I just say services.addMetrics. I can set various options here. So I can set my server to the machine name, which will be the Docker machine name when it's running inside Docker. The app is going to be my assembly name, so rocketstop.dll. Env I can use to get my ASP.NET Core environment and say either prod or staging or development. Then I'm going to add various types of output, serialization, text serialization, health checks, add the metrics middleware, add the reporting to send it out to Influx. These are the Influx settings, which we'll look at in a moment. And then I just say app.useMetrics and app.useMetrics reporting. Okay? So it's a lot of boilerplate code, but like I say, it's the same boilerplate code every time. You can either copy and paste it every time you create a new service, or you can stick it in there. I've put it between the bit that says use the developer exception page and use static files. So it's going to tell me how long it takes to serve static files, but it won't tell me how long it takes to serve error pages. I don't want it to do that because those error pages will catch errors and then the metrics won't get to see the errors. So when you're doing this configure application, it's in kind of reverse order. So it'll do the metrics, and then if it was an error, it'll carry on reporting that up to the error page, and then down at the bottom I've got my use MVC there. Okay? So if I go back to my docking thing here, and we go to metrics, you can see that this is picked up. This is just the JSON output for everything that's happened so far. Okay. And if I go to health, you can see my health checks that are in there. Now, if I Thank you. So yes, that tells me which health checks are healthy and which are degraded and so forth. So if I've got monitoring, I can be pinging that health check every 5 seconds and setting up alerts on dashboards or sending people text messages or whatever if something goes down. And it gives you details on what actually has gone down. So if you've got a microservice that depends on 2 databases and some kind of cloud service, it'll be able to tell you which of those 3 things has become unavailable or unhealthy. So you get your health check out of there. To implement a health check, all you have to do is create a class that inherits from the AppMetrics health check base class. It'll work with any dependency injection you've set up, so you don't need to worry about where you're getting your connection strings or anything from. And you can just say, do my connection string and set the connect time out to 5 seconds, try and open that, and if it works, then return healthy. If it doesn't work, AppMetrics will pick up the exception and incorporate that into the error report on the unhealthy status. Okay, so we've got our health check there just by creating that. You can have as many of those as you want, and it'll report them all healthy or all unhealthy when you get into the thing. And if we just do ping, then you just get pong back, which says, yes, this process is running. No idea whether it's healthy or not, but it's quite handy to know whether it's there at all. So that's fun, but what you really want when you're doing monitoring and metrics and all this sort of good stuff is reporting. You want lovely dashboards, don't you? You want those things that you see on radiators and so forth in like modern development shops and so forth. Now those, it's easy enough to set it up. You saw the chunk of code that was pushing stuff out to InfluxDB. And InfluxDB is a time series database. It's specifically designed just to record values over time. Useless for anything else, fantastic for monitoring and metrics. And AppMetrics will push stuff out to that. It'll also push it out to Graphite and Prometheus and various other sources if you want it to. To actually look at what's in your InfluxDB, you need to use Grafana. And so I'm going to go to go back to my browser. And I'm going to go to port 3000 because that's where I bound Grafana to. And I'm going to go to admin and log in there. And then I'm going to add my data source, and that's going to be http://influxdb:8086. And it's not Graphite, it's InfluxDB, and the database is AppMetrics. Okay? And this is going to be my default data source. And that's added. And that hasn't worked. Oh, yes, sorry. Influx. Actually, no, let's call it AppMetrics. I put the host in the wrong place. Right. Okay, success, data source is working. So now, in my lovely new world, I go to here and it says, oh, you need to create a new dashboard. And I go, how do I create it? And then it's got this thing here, and then I'm going to say, I want to graph, how do I add things to this graph? Grafana is quite complicated, okay? So now, this is my favorite thing about this AppMetrics project. The people who make Grafana run a kind of repository where you can put templates for dashboards, okay? And the guy who's done the AppMetrics open source library has created a template specifically for the output of the AppMetrics library. And so I can go to dashboards and say import, and I'm going to ignore my changes there. So I can either upload a JSON file, which I've exported from somewhere else, or I can get one from the Grafana dashboard. And the Grafana dashboard, so go to Grafana Labs here, and you can see we've got the AppMetrics web monitoring InfluxDB, and we've got a dashboard, and its identity is 2125. So I can go back to here and just say 2125, and it goes off and it finds it, and I'm going to say import that. and I immediately get this amazing, like brilliant dashboard where it's saying things are healthy. And if I go back to my rocket stop and I say Docker ship, and why have you, oh no, that's not the right one. That's why. Localhost 8081. And go to /docking, and then I can say Docker ship and put it in bay F, and I can dock the Millennium Falcon in there because I don't care. I'm going to mix Hitchhiker's Guide to the Galaxy and Star Wars, and if you don't like it, you can stop off. Okay, and then I can go back to my metrics dashboard here, and I've got my overview thing at the top here that's showing these are how many errors I've got, these are my requests per minute. It's like a proper dashboard, and I just had to type in 2125 to get it out. And now I can stick this, well actually what I can do now is I can play Forza Horizon 3 for the rest of the day, and then at 5:25 I can put this up on the big screen and pretend this is what I've been doing all day. So that's how I work. Does anyone want to hire me, by the way? No? You're mean. So, anyway, and all the instructions to do that are on the site. It's app-metrics.io. So that's the visual bit of what I could demonstrate. The stuff that is also outstanding that you need to worry about, and I'm going to recommend a couple of things to look at, but I haven't got time for the demos because the rest of it was so cool. But yes, the rabbit hole goes really, really, really deep, okay? So there's service discovery. Once you've got all these services up and running, you need to be able to find all the different services. It's okay for all the stuff you've got running inside Docker, whether you're running in Swarm or Kubernetes or whatever, because they provide DNS. So you just use the name of the service and you can see it. But if you've got things outside, like with 12-factor apps, you're talking to an Azure SQL database or a Postgres database or something external, then you need to put the URLs for that. So you need a distributed service discovery system. Something like Consul is great. That's from HashiCorp. There's etcd, there's Zookeeper. If you really want to just piss off your ops people, say get a Zookeeper cluster up and keep it running. That'll just take one of them completely out of the running. So yes, and for working with Consul and etcd, there's a library called Microphone that you can use, which is a little bit abandoned, but it works, okay? He just hasn't updated it for .NET Core 2.0 yet. The circuit breaker pattern, there's a couple of libraries for that. There's Poly, which is not just circuit breaker, it does a whole kind of exponential retries for kind of temporary partitions and so forth. There's also circuitbreaker.net, which is a more kind of literal circuit breaker library. There are other protocols that you're going to have to start looking at using. So HTTP is not necessarily the best, most efficient protocol for services in a microservice cluster to communicate. There are things like gRPC and Thrift, and there are libraries for running gRPC and Thrift protocols, client and server in C#. But according to David Fowler in the talk on ASP.NET Futures last night, one of the things they're looking to do with Kestrel is abstract the concept of HTTP away from Kestrel, so Kestrel becomes like a networking server, more like libuv, and then you'll be able to run gRPC or Thrift kind of directly on top of Kestrel. So that's going to be cool. There's actors. So once you get into this thing where you go, I've got hundreds of microservices and I'm distributing a job and pushing it out, and I want all of you to just solve different bits of this, and then we'll pull it all back in again and turn it into a response. So then you start looking at actor framework. So you've got Akka.NET, which is a literal port of the Java Akka framework. You've got Proto-Actor, which is a kind of what would happen if we started it from scratch. You've got Orleans, which is Microsoft's version of this thing. And so you need to start looking at those things as well. You've got distributed code, so you need things like buses and RabbitMQ and ZeroMQ and Redis for storing data that's being worked on by a whole bunch of different actors so that they can all pull it out and push it back in again and create collaborated results. The monitoring thing, which I don't have time to show you, which is Zipkin, Zipkin will mark a request when it comes into one service, and then you wrap it around your requests to other services, and it creates a distributed trace. So you get like a Gantt chart that says, okay, the overall request took this long, but this request within it took this long, and this request within that took that long. And it's like one of those function timer things that you get when you profile a .NET application, except it's run across the entire thing. It's based on a white paper by Google, but it was actually created by Twitter, and there's a C# library for it. Zipkin for Net is the one that works best at the moment. So there's all this sort of stuff to come as well in this new .NET world. And that's without even thinking that maybe now we've got this proper, modern, lightweight, open source, distributed code factory that we can use, maybe we can create something new like the Java guys have been doing and the Go guys have been doing, and we can do it in .NET and we can stick it out there. So go off and do it. Thank you very much.